Okay, so let me go to the course page. So I'll share my screen with you and we'll talk about the materials that you need. I also have a sample here that I want to show you. Guess I can share my screen. Okay, this is the course in Zoom. When you go to home, can you guys see my screen? Can you see the screen? Yes or no? Or you can...
Yes, sir. Yes, sir.
Okay, great. So when you go to home, this is what you see. We have a banner here, and the first module says welcome and course materials. When you click on that, we have the introduction page with my contact information, how you can contact me. We also have on the next page here, the course grading that tells you how you're going to be graded. I'll go over this in a second, but I want you to pay special attention to this page here where it says course materials, right? So what materials are available for you for this course? The first thing I want to discuss is what you need to purchase. So again, I have links here for a kit from Amazon that you need to purchase for the class. The first one is, like I said, is a parts kit. And the second one at the bottom here is a multimeter. There are some other tools here, software requirements that I shared with you that you can use to actually design your circuits on the computer or on the internet. But those that are mandatory is the first one here, which is a Amazon parts kit. This is what it takes you. So inside of this kit, we have a breadboard, so you can create the circuits. We have a microcontroller here, like I said, that will supply 5 volts. So we'll just be using USB power for this lab. And we also will program this in our project at the end. We have a number of LEDs that are available and also jumper wires as well. In addition to just a few sensors that are in this kit, and this kit costs $22. The next thing that is mandatory is a multimeter, and I put 2 options here for you. You have an option from Amazon. So this one costs $15 from Amazon. And there's another option from Harbor Freight. And this one costs, I think, about $7. So this is just a basic multimeter. So you will learn how to use this, and we will be doing our labs with it in this course as well. Okay, so again, these are non-negotiable. I would advise you to purchase them today, so you can have them, say, in about 1 week, so that when the lab assignments are due, you'll be able to perform them. Secondly, for some of the labs, I'm going to be available so that if you have questions, I can answer your questions during the session. If not, you will do them on your own. Okay, so this is the material I wanted to share with you. This is the breadboard, and this is what we use to create circuits, right? It has connectors in the rows here, and of course I will tell you more about this as we continue. And so to make a connection, you put 2 things in the same rows. So you have a breadboard in the kit, you have a number of resistors as well. These are resistors, we'll discuss them further. We also have jumper wires that we use to make connections, and we will also have the microcontroller here. And again, it's powered by USB. So you can plug this into your phone charger, or if you have a power bank, like I have a power bank right here, you can plug this into the power bank and you have access to 5 volts. You can see the light is, we'll have access to 5 volts that we can use to do our experiments. So most of the circuits that we're gonna build, the voltage for them will be 5 volts. And that's it. It's nothing difficult, nothing complicated. And then you have a multimeter. So you don't have to have the same kit that I recommended, as long as your kit is able to give you 5 volts, it's able to give you, you have resistors and so forth, and you have a multimeter, we'll be okay. We'll be able to work with it. Again, if you have any issues getting the kit and stuff like that, please let me know. So we'll see what accommodations we can have for you. Secondly, let us just briefly review the course. So let me share my screen again. So in here, So as you can see, the way the course is set up, we have a number of different modules. So here you have a module for introduction and course materials that you need to go through. We also have a section for lab 1. Okay, I think I'm in the wrong class. Just give me a second. We need to be in the class and not in the lab. But the lab and the class are going to be very similar. All right, so this is the class. And very similar here. So again, you have introduction materials here. You can find information about how the class is going to be graded. So let's go to the grades quickly. So again, here, when you go here, you see we have a start here page. We have course grading. We have some links for you that you can use, right? If you hit next, you'll still go through all these pages. So in here, we have the facilitator, contact information. Again here, if you notice here, we have a zip download here and it says course materials. Like I mentioned to you, there are lots of materials available to you that you can review. In this zip file, you have a number of PowerPoints. So you have a PowerPoint for each chapter. So you can go through this PowerPoint and it's like going through the textbook. And if you would read this material, this gives you what you need to complete all the quizzes as well. It also has a sample final exam as well in this zip file. I have the folder here. I can show you what's inside the file. So when you download the zip file, you will get all of these documents in here and a sample final exam. So if you look at chapter 1, you have a PDF of the presentations for chapter 1. So again, it talks about passive components, active components. All that you need to know is in here. Now, just to let you know, in the live or in the synchronous sessions that I'm going to record, sometimes I'm going to be using these presentations and sometimes I'm going to be using some other material, right? Just to let you know. So again, here, each chapter you have material that's presented to you. So the exercises are going to be based on these. So this is available to you. The link is right here. Download the course materials. We also have a classroom support discussion board. So if you have any questions that you think the class is going to benefit from, you can post it there. And of course, I will look at it and we'll respond. Let's go to the next. So how will this course be graded? So again, this being an online course, we don't only have homeworks, but I want to have discussion. So I want as you read that. So again, there are a number of course objectives for the class. And so the way you're going to meet the objectives is by, number one, taking time to go through the learning materials. And that could be watching the videos. It could be reading the presentations. It could be reading whatever handouts I assigned to you. That is part of the training for the course. Another part is by completing quizzes, testing your knowledge. We call that summative assessment. And then another part is doing assignments. That is also part of your learning for the course. Another part is participating in discussions. This also helps. The more you engage with the material, the more you can absorb it and understand it. And of course, then we have exams, which assess you as well. So again, if you look at the way you get points, we have quizzes for each module. We have a reflection where we have some reflection questions. For each module, we have a discussion board where we just ask you to briefly discuss. Sometimes you have to reply, so just please look at the instructions and you get some points for that. Then we also want your feedback. So after module 1, you share a feedback as to, what was the experience like? What can be changed? What should the instructor do to have a better learning experience for the next module? We have speaking demonstrations. So the university is embarking on improving oral communication for persons. So you will have an opportunity to orally share what you have learned about the material. Then we have attendance. So this is 5 points per session. And like I said, in this course, you can take the course totally asynchronously. What does that mean? It means you can take it at any time. You don't have to come to this session. You can take it at any time. And so if you're doing your work, right, you will get points for this attendance. You don't have to be in the session itself. Then we have assignments. So we have points for assignments, and also we have 450 points for exams. How will your grade be scored? Of course, you can look at the points, then we can determine your grade from that. Okay, very important. You have until 11:59 p.m. On June 22nd to complete all your work. So I'm not going to be on your back. Hey, you need to do this, but you have until this time to submit all your work. And of course, I want to encourage you. As soon as we're done with class, every day try to finish a module. Right? Every day, just go at it until you complete it. It doesn't mean you have to take the whole summer to do it. You just keep at it until you complete it. So it's possible that you can complete the course before we are done and just wait for the exam. Do not leave everything for last minute, because it's going to be frustrating. It may be possible to do it, but it's going to be frustrating. So just don't procrastinate. Just go ahead and take care of the work. Okay, the next we have here. Okay, we already discussed this. I already told you about the zip file. The other thing we have, there's some, I put some links for some free textbooks. So I'm recommending a textbook in my syllabus, but like I said, any textbook you have on electrical circuits is going to be sufficient. And so I have some links here for some free textbooks that you can use. Like I said, this material is not new. It has been around for a long time. So if you take the time, you will understand it. Let's continue. So we go to the next page. Okay, we have a page here with the link information. Now I also created an announcement with this information. I also sent an email to you with this information as well. Again, just to remind you that the meetings are going to be recorded so that persons who do not come to class, that they can see it as well. Okay, so here we are in module 1. So here we have our syllabus. We talk about workshop and the learning objectives for the class. Again, what are the learning objectives for this class? We want you to be able to explain the circuit components, so you know what the circuit components are. You can describe LEDs, voltage sources, current sources. You can describe what electricity is, how we use electrical energy, what are some electrical components, and how do we use this component, what are some applications, how do you calculate voltage, current, and resistance and power in different applications. Also, you need to be able to explain the combination of components, how that affects the current that is used, and so forth. You need to also be able to solve some electrical circuit problems using some basic laws like Ohm's law, voltage divider law, current dividers, Kirchhoff's laws, and some other circuit theorems as well. You need to be able to explain, and I'm going to make this a little bigger. Let's get rid of this. You need to also be able to explain the effect of circuit component. So just a second. Explain how we can use the Wheatstone bridge for instrumentation. We want to design an interface sensors with the microcontroller. Again, that's why the kit has a microcontroller. So we can actually create a circuit and get the microcontroller to collect information for us so we can complete the project with it. Also, we want to be able to learn how to use simulation tools. Okay, what is simulation? This is where we get a computer to represent our circuit, and we get the computer to calculate all the values that we would calculate ourselves manually. We get the computer to calculate this for us. We call that simulation. And so there are a number of free tools available. We definitely want to introduce you to those tools, and we want you to have the skills to be able to use them. We also want you to get practical hands-on experience with circuits. That is why the lab is not all online, but I want you to actually get your hands on the circuits so that you can be able to create them for yourselves and do the measurements for yourselves as well. Then we want you to be able to discuss the importance of quality, timeliness, continuous improvement, and also set points. And they're not difficult, so like I said, just take some time. You can knock them out easily. So each session we have, like I said, we have about 9 of them. We will have an assessment, we have a discussion, we have a reflection, we have share, we have assignment. For the speaking demonstrations, I'm going to give you some advance notice. And of course, I will get you to share on Zoom. So persons who are not able to make it, I'm going to ask them to submit a recording. What are some topics we will discuss? Again, we will discuss energy, power, resistance, Ohm's law. And again, these dates are from last year. Circuit analysis and so forth. Let's go on to the next page. Again, this is the class. Like I mentioned, we have a classroom support discussion board. If you have questions, you can put it in there. Everyone can see it, everyone can respond. And then we have the university resources. Like again, you should know about the policies of the university and about what they recommend, so you can have the best experience on campus. So I'm not going to cover that. It's there for you to go through it. Okay, let's go to module 1. Let's see, what time do we have? Okay, so we have 10 more minutes. Let's go to session 1. And so you see the general layout of the sessions. So again, in session 1 here, we have getting started. We have, for each session, we're going to have a short overview. The session will cover introduction to the course overview, participant introductions, introduction to electrical engineering, what are the objectives, to recall the components of the workshop shell, to explain the origin of electrical energy, and to explain energy conservation and the importance of high efficiency standards and ratings. So again, we have already gone over the shell of the course, and so we're already meeting those objectives. And so we'll talk about energy, what is electrical energy, and why it's important to conserve energy. What are we going to evaluate you at the end? We want to evaluate the benefits of electrical energy over other forms. So we're at the end of this 10 minutes, we will be seeing, why is electrical energy favored over many other types of energy. Then we want to talk about efficiency. What is efficiency and why is high efficiency important? And then we also want to identify various energy efficiency standards. So this is where the link is going to go. Of course, this link is from last year. It's not good. So at the end of this recording, I'm going to put a link there so persons who are late to the course or who will do it asynchronously, they will have that information. Any materials that we cover in the course is going to be here. So you can see I already included the chapter 1 presentation, chapter 2, and some handouts here for you. Let's go on to the next page. So we have the first page is like an introduction to the session. The second page is the content, and the third page is where you have all the assignments. So again, here we talk about the origin of electrical energy. All right. So let's discuss this. It says engineers are continuously devising new ways to store and transport and create electricity. They develop new types of batteries, safer transmission lines, and power plants. Examples include solar, small compact batteries, and rubber insulated power lines. Electrical and computer engineers design systems that produce electricity and transport it to your home. Electrical engineers work with electricity in all its forms, from tiny electrons to large-scale magnetic fields to everyday appliances. Teams of engineers develop complex devices such as lasers used in medical treatments or robots that perform complex operations in space. Electrical energy is based on charged particles in atoms. The electrons, which have a negative charge, absorb thermal energy from the surroundings or from an electric field through the material. When the electrons stay on place, this static charge. So when the electrons stay in one place, we said that this is static charge. When the electrons leave the atoms, they become free electrons, and this is electrical current. So we will see that electricity has to do with the atom, and it has to do with electrons leaving the parent atom and being free electrons, and these electrons now move through the material. And of course, the material is normally a metal, or it could be a liquid. The electrons move about, and we call these free electrons. Current is the rate flow. So how many, based on the amount of electrons that are moving, we can actually find the current that is flowing. Current is the rate flow of charge. Now, the reason why we use charge is because each electron has a particular amount of negative charge, right? So again, electricity has to do with the movement of electrons, And since each electron has a negative charge, we also define it as the movement of charge. And we also use current to describe this, because current is telling us how much charge moves in 1 second. Okay, and of course I'll give you more on this. How does electrical energy reach our home? Okay, it reaches our homes through transmission lines, right? In most cases, we have fossil fuels, which is coal and oil, are burned in a furnace, and the heat is used to produce steam that turns turbines that are connected to generators. A spinning magnet in a generator changes the charge in a coil windings, causing current to flow. So what you will see as we continue the course is that magnetism is very closely related to electricity, right? Again, magnetism is very closely related to electricity, even to the fact that generators that produce electricity, they use magnets. And so we will discuss more on this. So we have two types of electricity that we are going to discuss. We have AC, which is alternating current, and we have DC. And we have two short videos describing each of those for you to watch. Again, direct current is where the electrons flow in one direction. So if you look at this battery here, you see that the charge is, if I play this.
Hi there, I'm William Mack, coming from our Cake Lab.
Okay, you may not be able to hear this. Let me just stop it. Let me stop it and share it again.
In Fort Lauderdale, Florida. We use electricity every day, but have you ever asked, what is electricity? In its most basic form, electricity is a movement of electric charge. On a large scale, this looks like a lightning strike. On a much smaller scale, it lets you send memes and GIFs to your friends, instead of actually talking to them. In a circuit diagram, we show electric current flowing from the positive side of a battery or a power supply to the negative side. And it's been that way since Benjamin Franklin attached a key to a kite string and flew it into some really bad weather. Fun fact, this is actually kind of backwards and is known as conventional current theory. With a few exceptions, electric current is made up of electrons, which are negatively charged and flow from the negative terminal to the positive terminal. So
I'm gonna pause this right there. Again, so just so you can see, we have direct current, which flows in where electrons flow in one direction. And we said, as the electrons are moving, each electron has a particular amount of negative charge. So we don't count how many electrons are moving. Instead, we count how much charge is moving. And actually the number of charge, that amount of charge that moves in 1 second, we call that the current, as you will see. We also have alternating current, where the electrons move forward and backwards. And they move forward and backwards at the rate of 60 hertz per second. And this is what is used mainly for main electric generation and also transmission. So the power that comes to your home is in the form of AC.
Hi there, I'm William Charger. You actually have both because those convert AC to DC. Current is proportional to voltage. The current flows from the positive side of the supply to the negative side. With AC, the current flows back and forth. So we covered how AC and...
So again, let me just show it again. You will see that for AC, the current flows back and forth.
In the US, you can decide to also see this by looking at how current flows. With DC, current flows from the positive side of the supply to the negative side. With AC, the current flows back and forth.
Okay, so you can see here that for AC, the electrons are flowing back and forth, right? That's how they're generated. And for DC, they're flowing in just one direction. So the last thing I want to show you before we end, on this page here, there's also some resources that talks about energy efficiency, right? Now, before we go, I have some definitions here that I gave to you. What is efficiency? Like we said, when you look at the rules for energy, the rule states that there's a rule called the conservation of electric energy. And that rule says that energy cannot be created or destroyed. It can only be transferred from one form to another, right? Energy cannot be created or destroyed. It can only be converted from one form to another. So I have a light right here coming to my face. That light is converting electric energy into light energy and also heat energy, right? If you look at the light above me, same thing. It's converting electric energy into light energy and heat energy. If you take your iron, some of you iron your clothes this morning, that is converting the electric energy into thermal energy, right? And you can go, there are many other examples. So what is efficiency? Efficiency is how well the energy is converted. So for example, you have an electric motor and you want to convert your electric energy into kinetic energy or motion. Then you're going to have some heat generated, right? So some energy is going to be converted to heat. In other words, anytime you do a conversion, 100% of your energy does not go to the form that you want, like a light bulb. You convert electric energy to light, but some is generated as heat. And in a sense, you can say that is lost, right? So efficiency is a measure of the desired energy over the total input. For example, a light bulb. Say you have 100 joules of energy, and you want that your light bulb gives you 80 joules of light, right, and 20 joules of heat. Your efficiency is going to be your desired energy, which is 80 joules of light, divided by your total input, which is 100 joules of energy. And so you can see that light bulb is 80% efficient. So this is efficiency, how well we are able to convert the energy to the desired form. And so of course, we want our components or whatever we design to have very high efficiency. Just as we end the recording, I want to show you the last page, which is the assessment page. So again, you need to take time to go through the material on this content slide. And then you can go ahead and look at the next page, which is the assessments. And again, here we have a discussion board. We have an assessment that you should take, it's a quiz. We have a discussion that you should participate in. We have a reflection that you should complete. And we have a share where you can share your experience. Okay, any questions for me? And again, this is the format we're going to use going forward. So we have a lecture, and then we have content page. We have then a assessment page where you go and complete the assessments.
Mr. Lane?
Yes.
Is there a due date by the time we should have the materials for the lab?
So I say if you try to order it today, hopefully by next week you can have it in hand.
Okay, yes, sir. And when do you think we'll start using them? I'm thinking about to go ahead and order it right now, actually. Okay,
well, we're gonna we'll start using them this week. So,
yes,
so for example, I'm going to be doing the lab with it. I'll be showing you all the steps. Now you may not have it, but there's something that you need to do as part of the lab. So the part where it comes to creating the circuit, you will not be able to complete, right? But there are some other parts that you'll be able to do, but I will be doing it as well. So I would say this week.
Okay, yes, sir. Thank you.